Okay, let's talk about computers. I mean, we use them for literally everything, right? For work, for play, for just about anything you can think of. But have you ever, really stopped to ask yourself, what is a computer? What's actually going on in there? Well, that's what we're going to do today. We're going to peel back the layers and really demystify the machine that, let's be honest, runs our entire world.
You know that feeling? You click a mouse, tap a screen, and poof, a whole world just appears. It feels like magic, doesn't it? But it's not. Believe it or not, it's just a super fast series of really logical steps. And over the next few minutes, we're going to break down exactly what those steps are. So if you boil it all down to its most basic, simple form, this is it. A computer is just an electronic machine that takes in some data, does something to it, and then gives you an output. That's it. It sounds almost too simple, right? But the real secret, the magic, is in the how. How does it actually do all that?
All right, to get that how, we need to talk about the two fundamental parts of any computer. Seriously, every single one has them. Just think of it like a person. You've got a body, and you've got a mind. The hardware is the body, all the physical stuff you can actually touch. And the software, that's the mind, the invisible instructions that tell the body what to do. Let's dig into that a little more. The hardware is the body, right? We're talking about the screen, the keyboard, the little chips and wires inside. Basically, if you can pick it up and hold it, it's hardware. But a body with no mind is just a lump. It can't do anything. That's where software comes in. It's the set of instructions, the thoughts, that makes the hardware wake up and do something useful. You absolutely cannot have one without the other.
So let's start with the hardware, the physical stuff. First, you've got your input devices. This is how you tell the computer what to do. Your keyboard, your mouse, your microphone. Then you have output devices. This is how the computer shows you what it's done. The monitor, the speakers, a printer. It also needs a place to keep things, right? That's your storage devices, like an old-school hard drive or one of those newer super-fast SSDs. And then there's the big one, the part that runs the whole show, the central processing unit, or CPU. We're definitely coming back to that guy.
Okay, now for the other half, the software, the mind. Think of it in layers. At the very bottom, you have your system software. That's your operating system, like Windows or Mac OS, that basically manages all the hardware and makes it work together. Then, on top of that, you have application software. These are the apps you actually use every day. Chrome, your favorite game, you name it. And way up at the top, you've got programming software. These are just the special tools that developers use to build all the other software. It's all just code, bringing that physical hardware to life.
So we've got the body, the hardware, and the mind, the software. How do they actually work together? Well, it all comes down to this simple, constant, three-step dance. And I'm not kidding. This one process is behind everything your computer does, from sending a simple email to playing a 4K video.
They call it the IPO cycle. Input, process, output. And honestly, the best way to think about it is like baking a cake. Seriously. Step 1, input. You gather your ingredients, flour, sugar, eggs. That's your data. Step 2, processing. You mix it all together and bake it. The computer's doing its work. And step 3, output. You get a delicious cake. That's your result. Every single thing a computer does, big or small, follows this exact recipe.
All right, let's zoom in on that middle step, the processing part. This is where we get back to that thing I mentioned earlier, the CPU, the central processing unit. This little chip is, without a doubt, the brain of the whole operation. And it is working at a speed that's just hard to even imagine, making billions with a B of calculations every single second. And inside that little brain, you've basically got a three-part team. First up is the ALU, the Arithmetic Logic Unit. Think of it as the CPU's calculator. It does all the math and makes all the logical decisions. Then you've got the CU, the Control Unit. This is the traffic cop, telling all the data where to go and when. And finally, you have the registers. These are like a tiny, ridiculously fast notepad that the CPU uses to jot down what it's working on right this second.
Now, of course, a brain isn't much good without memory, right? And computers have two main types. First, there's primary memory, which you probably know as RAM. The best analogy is your workbench or your desk. It's where you put all the stuff you're working on right now. It's super fast to grab things from, but when you're done for the day and turn off the power, the desk gets wiped clean. Then you have secondary memory. This is your hard drive or SSD. Think of this as your long-term filing cabinet. It might be a little slower to find things, but anything you put in there stays, even when the power is off.
Okay, so there you have it. That's the basic recipe, right? You take hardware, you add software, and you make them work together in that constant input-process-output cycle. Now let's kind of zoom back out and see how that one simple formula is used to build all the different kinds of computers we see in the world. And believe me, it is a huge family tree. At the very top, you have these absolute monsters called supercomputers, giant machines built for one specific, massive job, like predicting the weather. A step down from that, you have mainframes, which big companies like banks use to handle enormous amounts of transactions. Then we get to the stuff we use every day. Microcomputers, that's just a fancy name for our PCs and laptops, and of course, the mobile devices we carry around everywhere. They all work on the exact same principles, just on a wildly different scale.
But here's the thing about computers today. They almost never work alone. The real magic, the real power, happens when we start connecting them all together. That's when you create something way bigger and more powerful than any single machine.
And those connections are called networks. You've definitely heard of these. A LAN, or local area network, is probably what you have in your house. It's your Wi-Fi network, connecting your laptop, your phone, maybe your smart TV, all in one small area. But a WAN, a wide area network, is much, much bigger. Think about a huge company connecting all its offices in different cities or even different countries. So, what's the ultimate WAN? The biggest one of all? Yep, it's the internet. That's all it is, really. It's a massive global network connecting billions of computers, all of them able to share information with each other in an instant. So why should you care about any of this? Because that simple little loop, input, process, output, when you run it on billions of connected machines, it changes everything. Just think about your day so far. How you learn, how you handle your money, how you're entertained, even how modern medicine works. It's all powered by computers. They're the invisible engine that runs our entire world now. So there you have it. From a single click of a mouse all the way to a global, interconnected society. It all comes back to that one simple idea: input, process, output. It's a concept that has totally remade our world in just a handful of decades, which leaves us with one really big question, right? What's it going to change next?